Hello everyone, welcome to this session in which we'll be covering the subject NTM non-traditional machining. So I have separately created a note for EDM. Uh, I'm not sure whether the recording covers the tab switching and all. In the syllabus, we can see that we have half part of the module 4 is about EDM. The remaining half consists about the parameters of EDM, which is very small, and its application limited advantage very small. Then they talk about electric grinding and wire EDM. It's just same but different like that. So everything you have to repeat the same, but just one or two points you have to add extra. In here we'll be doing about grinding, and here wire EDM. So instead of generating spark, we'll be using a wire which will be rolling around the workpiece and will cut. So we'll see here. This is uh, yeah, see, this is the diagram which I generated from AI for electrical discharging machining. So basically, what is the mechanism? So will dip the workpiece into a dielectric fluid. Okay, so you can see the workpiece, that is a metal. It is dipped in dielectric fluid. It can be any kerosene, transformer oil, or deionized water. So basically, this water you can see here, this dielectric fluid is insulator. So meaning what? Current won't pass from it. So now the tool, see, you can see the workpiece and the tool. There will be a gap in that, so spark gap. Okay, so among that gap, what happens? The current which is there here, it will a voltage will be supplied to this dielectric fluid between the workpiece and the tool. So now what happens at a certain level, like like how the water boils at 100 degree, the same way at a certain voltage, that is nothing but breakdown voltage. At that particular voltage value, what will happen? This dielectric fluid, instead of being insulator, it becomes conductive, and then what happens? The spark is formed and the metal is what to say, melted. The workpiece is melted and the molten pool is formed. So you can see here, see, a molten pool is formed here, and the the spark will actually cut the workpiece, and the dielectric fluid will be there, right? So there are different types of flushing mechanism in which the dielectric fluids, you can see this flushing system. This thing is pouring the water, right? So once it is melted, you can see this some debris type of thing. It is accumulated, that has to be cleaned away. If it is not cleaned away, then it will result in poor surface finish, and that again will cause some some hollow type of thing like marks. It will leave marks or scratches type of in the workpiece, so it is not good for that. So that should be washed away. That is done by flushing system. So that's the mechanism. So you have pulse DC power supply. So here what happens? We cannot continuously supply this voltage and all, because at a certain we have to apply the voltage, then stop it, because if you don't stop, then complete workpiece will melt. So you have servo control mechanism system with nothing but which manages or maintains the flow of feed of this tool, so up and down movement. So if you move the tool very close to the workpiece, then no voltage will be supplied, no spark generation. If you take two up, then less voltage, and spark cannot hit the workpiece itself, low spark. If you keep in the optimal distance, then only it will help. So this is the mechanism. We'll see what is electrolysis machining, the non-traditional machining process. I always mention for every process where material is removed from a conductive workpiece. See, conductive workpiece by a series of rapid repetitive electrical spark between a tool, electron, and the work. This is in the presence of dielectric fluid. So this water is nothing but dielectric fluid. Basic principle: see, tool and workpiece separated by a small gap. See, that is nothing but spark gap, 0.01 to 0.5 mm. Both immersed in dielectric fluid. It can be oil, kerosene, or deionized water. High voltage pulse applies between them. Each pulse creates a spark. So see, pulse is nothing but like heartbeat. So it will come. See, can I draw? So see, it will come like this. It will go up and it will go down. It will come. Voltage increase, then voltage will decrease. Voltage will increase like heartbeat. See, pulse up and down. So there is nothing. So at each pulse, when it goes up, the spark will be generated. So spark generate intense heat. Material melts and vaporizes. See, sometimes the material, when it will melts, right, either it will form a crater like bubble type of thing, very thin layer bubble. If you tap, it will break like pani puri, or else something will instantly vaporizes into thin air and flows away, and sometimes it forms that debris and all. Directly fluid cools and flushes away debris. Mechanism of material removal, you have how many stages? Five stages. Gap ionization, breakdown, discharge. So gap ionization is nothing but pre-breakdown. Here what will happen, you will prepare the workpiece for dip into the ionized water, and then the voltage will be supplied. So the you can see in the notes which I have created. So if you go to the first page, see here stage 1. I don't know if you can see, but I'll be reading it out, right? So tool and workpiece separated to small gap, both immersed in dielectric fluid, voltage applied across gap. Initially no current flows, electric field builds up across the gap. So whatever the gap is, so I can draw here, right? So see, the workpiece is here and the tool is here. So this is the gap, right? In this gap, what happens? So it is filled with all that what to say, fluid and all. I should have drawn in different colors. So what will happen as soon as the current is passed, that voltage, so it will increase the what to say, it will be keep on increasing the voltage, and then suddenly this insulator dielectric fluid will become conductive, and then the spark will happen. Breakdown is nothing but the voltage at which, breakdown voltage, a value of voltage or threshold of voltage at which the insulative dielectric fluid will become conductive, and the spark will be generated. So in what happens, voltage increases to breakdown voltage, dielectric fluid ionizes at weakest point, forms conductive plasma channel. Plasma channel is nothing but, you can see this gap. See, that is nothing but a plasma channel. Then electron rush from cathode to anode, current flows through plasma channel. This happens in nanoseconds. Sparks form. So current flows in this between these channels. So that is the spark. The actual spark will go between this, and that will happen. Discharge material. So here discharge is nothing but material intense heat generation. So the spark which is forming, it is around 8,000 to 12,000 degrees Celsius. So that heat is generated. Material melts. Sometimes it will melt, forming a crater type of thing. Material vaporization. Sometimes the material vaporizes. Material ejection. So you have to remove the metal by flushing or something like that. See, spark creates shock waves and pressures. Molten metal ejected from both surfaces forms small crater on workpiece. Also forms craters on tool. Then you have fourth stages, off time, cooling and flushing. Pulse ends. So in the sense, what the pulse voltage will be reducing, the temperature will decrease, dietary fluid will cool down the metal. Flushing, removing the excessive material from the workpiece, that is nothing but debris and all, or crater removal. Deionization. So again, the dietary fluid is deionized. So when the voltage is applied, it gets ionized at certain temperature. Then should be deionized. Then cycle repeats. Again, what happens? Gap. So the voltage is applied again. So same thing is repeated. Spark frequency, you have to talk about this, 200 to 500 kilohertz sparks per second. So from one spark, like very so many sparks are generated, which will melt the workpiece. Typically 10,000 to 50,000 sparks per second. Okay, then you have ADM equipment, 5 component: power supply, tool, electro, workpiece, dielectric system, servo control, and work tank. See, work tank is nothing but the tank in which you can see this tank, right? In which the workpiece is placed and the fluid is put. Then tool, see, you can talk. Tool is nothing but you have to talk about what it is made of, how it is used and all. Workpiece can be conductive workpiece. Okay, then so three things are over here. So tool, electrode, workpiece, work tank. So tool should be cathode, work should be anode, work tank. So servo control field system is a head which controls the direction movement of the tool up and down. So if you maintain lower gap, no voltage is passed, very no MRR, low MRR, like no MRR itself, and sometimes no good surface finish, like because it won't be working itself. If you take more away, very far gap, much higher gap, spark won't be hitting properly the what to say, workpiece, and very low MRR and low surfaces. You have to maintain the optimal gap, that is 0.01 to 0.05 mm. Then what about power supply? Spark generator provide control electrical pulse to create spark between tool and workpiece. Power supply is nothing but this pulse DC power supply. So it will be generating the power in the form of pulse. So it won't supply the current continuously. Control the electrical pulses supplied to the cathode electrode, which will generate the spark. Functions of dielectric fluid. So dielectric fluid is nothing but which acts as the insulator. We'll see here. See, dielectric fluid, too much. So you have spark power supply, spark erosion generator. You have three types of EDM generators are there, but in the syllabus you have only relaxation type circuit. It's very simple. You have to know only about these four things. and then you can simply write any like similar or own advantage disadvantages. You have only charge phase and discharge phase, very easy. That's it is a electrically insulating fluid that surrounds a tool and workpiece during EDM. When voltage is applied, it acts as insulator. When breakdown occurs, it becomes conductor momentarily. So you can hydrocarbon oils, nothing but kerosene and transformer oil, deionized water. This is, for wired EDM, synthetic fluid, especially special applications. Then see functions, electrically insulation. So as insulator between pulse, so prevents continuous arcing. In a sense, continuous removal of the workpiece allows voltage to build up. Breakdowns only when voltage is high enough. Controls where spark occurs. So I can distribute this in different this. See, 4 point like that. Spark medium provides medium for spark formation. Ionizes to form conductive. So this is separate. Ionizes to form conductive plasma channel. Controls spark energy and characteristics. Cooling absorbs heat from the spark zone. Cools molten metal rapidly. That is nothing but quenching. Prevents excessive thermal damage to workpiece. Maintains tool and workpiece at stable temperature. Typically, so cooling nothing. Oh, uh, P. Yeah, caps. Then flushing carries away debris particle. So flushing is nothing but you have to remove the unnecessary that particles and all from that. Deionization again you have to regain the deionization properties of the what to say dietary fluid so that it can be used again for the next cycle. Protection from oxidation. So the fluid should not oxidize the metal or cause some corrosion or rusting to the metal. It shouldn't do. Mostly deionized water is very best and very good for that, but it can cause this oxidation and all. I hope this was useful for you. Then you have properties, high dielectric strength. So in the sense what when the current is applied, immediately it shouldn't get ionize and form the conduct. It shouldn't become conductive very immediately. So it should withstand high voltage and all. And low viscosity is nothing but how the how smoothly it will flow from the nozzle, like the direct fluid, how it will be flowing smoothly. So you can just think like how thin it is, like density should be very low. So water is has the very least viscosity. Then kerosene has low viscosity as well. High flash point nothing but how prone it is to getting catching fire. So for example, if you for something if you apply fire that you have a gun type of fire, right, where if you apply the when you hit the fire on the wood, immediately it won't burn, but after a certain time it will burn. So it's like that. So high flash point sensing, if you apply current, so it is like current you're applying, so at a certain temperature it will catch fire. So that is what flash point, the temperature at which it will catch the fire. So basically kerosene will catch fire very fast, but deionized water will never catch fire. Whereas what is the transformer oil will catch fire around 140 to 160 degrees, so it's very good. Fast deionization after the spark indol is done, after the voltage pulse is off, it should deionize fast. Chemical stable, so it shouldn't affect the workpiece. It should be chemically stable. We can see again about chemical stability. Should not decompose excessive at spark temperature. Long bath life. Non-corrosive shouldn't corrode the workpiece. Non-toxic, the fumes and all, which it shouldn't be toxin and all. Inhaling it shouldn't affect the human respiratory. Low cost and economically it's available. Servo control mechanism, the same thing I told. The this thing servo control, how it will be controlling the feed of the see gap voltage sensor. So it monitors voltage across the gap automatically. It will be always monitoring this voltage across the gap, and it will check whether the voltage with a reference voltage compare actual voltage reference. It drives the tool feed mechanism, converts motor rotation to linear rotation. You just have to remember four things. Over. Types of servo control: electrochemical servo, hydraulic servo, CNS. So here you should talk about only DC motor, very common. Hydraulic servo, so where it's high precision machine, very fast response, like hydraulic cylinder is used. Then CNC is a modern computer controlled stepper motor. Okay, so here it's modern and all, multi-axis axis. So this completes about complete half of the module. This is the part I have marked green. In the next part, we can easily check about EDM process parameters and all. It's very easy, very small, so it requires very less times. And similarly, the same procedure is applied for plasma arc machining. The only difference is that one or two components will be different. It's non-thermal, so here the heat generation is not there. Non-thermal generation, you won't be generating plasma with heat and all. So we'll see that in the next video.